second AP review. This is 2014 AB BC free response 3. The function f is defined in the closed interval from -4 to 5. The graph of f consists of 3 line segments shown in this diagram, but better on the real AP diagram. Let g be the function defined by g of x is the integral from -3 to x of f of t dt. All right, part A, find g of 3. All right, so A, g of 3 is going to be the integral from -3 to 3 of f of t dt, right? So what that means is the area from -3, right, to 3, which is going to be here, right? So we need to find the area of this triangle and add it to the area of this triangle, but this triangle will have a negative area, right? So what that's going to be, this triangle has a height of 4, right? 1, 2, 3, 4, and a base of 1, 2, 3, 4, 5, right? So essentially we have this big positive triangle that has a base of 5 and a height of 4, and it's going to be a positive value, right? Plus, with this little negative triangle, and you can figure out the slope of these guys here. The slope is down to right 1, so this has a base of 1 and a height of 2, or -2, but either way, it has to net negative because it's below the axis. So, plus this negative times the area of this triangle, which is, well, I didn't draw it upside down, my bad. So the area of this triangle, which is a 1 and a 2, right? So what's going to happen is I'm going to get 1/2 the base times the height, plus this will end up being a 1/2 times the 1 times, if you want to just put the negative on the height, that's fine. So you end up getting that this is a 1/2 of a 20, which is a 10, plus a 1/2 of a -2, which is a -1. So you end up getting an area of 9, which is your answer. Cool. Part B. On what open intervals contained between -5 and 4 is the graph of g both increasing and concave down? Give a reason for your answer. So this is one of those times that we're going to want to make a flow chart of what we need. But before we bother to do any of that, I think we should go ahead and find some derivatives of g, right? So the derivative of g, right, g prime of x, would be the derivative of this integral, which is just going to be f of x, because based on the second fundamental theorem of calculus, if you derive an integral, f of t dt, these cancel, and essentially this gets plugged in here, derivative of this, minus this thing times the derivative of this. So what ends up happening is my g prime of x is just f of x, right? It's the given graph. And my g double prime of x then is f prime of x, right? So what I want to point out here is that means that g prime is the y values on the given graph, right? And that my g double prime is the derivative of the given graph, meaning it's the slope of the given graph. So those are the relationships that we're going to need to make. These relationships are going to end up being really important in a second when we're trying to figure this out. So I like to make a flow chart when I go through this stuff. So in part B, here's what they asked me. They asked me for 2 things. I'm going to consider them both separately. First thing they asked is, when is g increasing? G increasing, okay? The other thing they asked, and they did say both, so we're going to talk about that in a sec, they asked for when g is concave down. So g concave down. Notice that I didn't just write increasing, I wrote g is increasing, because there are a lot of functions here. There's g, there's f, there's g prime, there's f prime, there's g double prime, there's f double prime, there's a lot of functions. You need to be specific. I'm then going to translate that into the actual mathematical definition. That's the next thing in my flowchart. So the definition of g increasing is that g prime of x is greater than 0. Right? And if we go over to what that tells me about what I can see with my eyeballs in this graph, right? What I can see with my eyes is g prime is the same as the y value on this graph. So I'm looking for where f of x is greater than 0, meaning the given graph is above the x-axis. That's what I'm looking for with my eyeballs, which means I can find those spots in a minute, right? Now let's talk about what it means for g to be concave down. G being concave down means that g double prime of x is less than 0, right? But we've established that d double prime of x is the same as f prime of x, so what I'm really looking for is where f prime of x is less than 0, meaning the given graph has a negative slope, right? Negative slope, or you could say is decreasing, right? Those are the 2 ways to look at that. You want where the given graph has a negative slope or is decreasing. That's what I'm looking for with my eyeballs, right? So now let's put those 2 pieces together, all right? So I'm going to use blue for f of x greater than 0, right? F of x is greater than 0 here and here and here, right? That whole blue interval. And I'm going to use red for when f prime of x is less than 0, meaning that the given graph is decreasing. So graph is decreasing, right? Decreasing right here, and it's decreasing again all the way over here. Well, the answer I want is where the blue and the red overlap. So the two intervals, like the intervals that meet both of these qualities together, are the open interval, because they said specifically use the open interval, right? The open interval from -5 to -3, right? -5 to -3. And also the interval from 0 to 2, right? Because 2 is where that hits the axis. I kind of messed it up by writing all over it, but 0 to 2. So those are my answers. I want the interval from -5 to -3 and 0 to 2, right? Those are the intervals that I want. Now, you were asked to justify your answer or give a reason, but if you do the flowchart method, you've definitely given a reason for your answer, right? Because you've clearly stated this is what I was looking for here, this is what I was looking for here, and here's my answer. So these are my reason, they're my justification. That last line where I talk about what I can see with my eyeballs based on the given graph, that's my justification, but I got there by starting with what I was asked, changing it to the mathy definition, and then connecting that to what I'm given in this particular problem and what I can see with my eyeballs. Remember, the fancy way to say I saw that with my eyeballs was by visual observation. By visual observation, puppies. I don't know. I don't know what you're observing. Maybe you're not observing puppies. Part C. Let H be defined as g of x over 5x. What is H prime of 3? Okay, cool. So this is fun because this tests a little bit of, well, I'm going to erase this because I know what it says, and I'll go from there. Okay, so this is testing your knowledge of the quotient rule and the chain rule and just some other good fun stuff. So h of x is g of x over 5x, right? So they want h prime of 3, which means I need to find h prime of x. Well, this is a quotient rule, right? This is a high function, this is my low function. So low, which is 5x, d high would be g prime of x, right? Minus high, which is g of x, d low, which is 5, right? Draw the line, square the low, which would be a 5x quantity squared. Great. So now we want h prime of 3, which means we need to have 5 times 3 times g prime of 3 minus g of 3 times 5 all over 5 times 3, which is a 15 quantity squared. Okay, cool. So we need, before we can do this, we need g of 3, but conveniently we already have g of 3 because this was part A, right? In part A, we found that g of 3 was a 9. Now, let's say you'd found that wrong in part A. You should still use your wrong answer. Cool, that's fine. We also need g prime of 3 to do this. Well, remember, g prime, right? So if we want to relate what g prime is, remember that we know that g prime of x was just f of x. So that means that g prime of 3 is really just the y value on the graph at 3, right? So we can see right here that the y value of the graph at 3, it's 3 comma -2. So this is a -2. So all I need to do now is clean up my numbers. So this is a 5 times 3, which is 15, times a -2. That's -30, right? This is minus a 9 times 5, so minus 45, right? All over a 225, so that's a -75 over 225. Now, honestly, if you wanted to leave it that way, I can't fault you. That's not a wrong answer, and there's not a huge reason to clean it up. But if you want, you can cancel some 25s, right? Because this is 3 times 25, and this is not, oh, you could do better than 25s, actually. I lied. You could cancel a 75, because that's 75 times 3. Yep, checks out. So you end up getting a -1/3. Now, that said, I don't know that it's actually worth doing it, right? You might just want to leave it as -75 over 125. All right, that's part C. Let's do part D. For part D, I would love to be able to erase this graph because it's all in my space, but we'll see. Okay, so for part D, let P be defined as f of x squared minus x, meaning f of the quantity x squared minus x. So in part D, P of x is f of x squared minus x. Cool. Here's our chain rule test. Find the slope of the line tangent to the graph P at the point where x is -1. So what they want P prime of -1, right? In order to find that, I need to start by finding P prime. So P prime of x, it's going to be a chain rule. The derivative of f is f prime of the stuff times the derivative of the stuff, right? That's the chain rule. So if I want P prime of -1, I'm going to need f prime of, well, this will be a positive 1, right? 1 minus a -1, so it'll be f prime of 2. And then in here, this is going to be a -2 minus 1, which is a -3. So I need whatever -3 times f prime of 2 is. Well, f prime of 2 is going to be the slope of this curve, right? So this is f. This thing has a slope of, so at 2, right, you'll see you go down 4, right 2. This is a line, right? So this is a line that right here has a slope of -4 over 2, right? Which is -2. So this should be a -3 times a -2, which means I get a 6. So P prime of -1 is a 6. And that's my answer. The end.